You may have owned or seen Fiesta Ware before. This brightly colored ceramic dinnerware is commonly used at Mexican restaurants, and it was the first mass-marketed solid colored dinnerware. It was sold in various incarnations starting in the 1930s and is still sold today. But did you know that up until the 1970s, the glaze used to coat the ceramics was made with uranium? So why did they use uranium, and does it make Fiesta Ware dangerous? First, we'll start with why. Well, the use of uranium oxide in ceramic glazes produces very vibrant colors, and the uranium can handle the high temperature firing process that ceramics must all go through. And while this was used in many colors, it was particularly used in red ceramics, and the Fiesta Ware Fiesta Red was one of the most popular ones of these. Now, I also think that the use of uranium was part of a general trend at the time to use these relatively newly found and newly understood radioactive materials in as many uses as possible. Like so often happens with new discoveries, we really want to use our new toys. For example, look how everything has AI integrated into it right now. From creating AI art to developing AI toothbrushes that monitor your brushing habits and recommend better ways to brush, I'm not making this up. It's pretty much everywhere nowadays. And the same thing was going on at the time with radioactive stuff. There were attempted and advertised uses of radioactive items everywhere. From advertising the health benefits of bathing in radioactive hot springs and selling devices that put radium in your drinking water, to the use of radium paint in clock and watch dials, it was everywhere. And this was also around the time that uranium glass started to be made. This was glass that actually contained uranium and phosphoresced when exposed to specific wavelengths of light. And it looks like the glass that you see behind me here lit with a black light. Now, even though these particular pieces were advertised as uranium glass, I'm pretty sure they're manganese glass because when I checked in with my radiation detector, they read about what background radiation levels are in this area. So if you want to make sure you're getting actual uranium glass, you want to make sure you take a radiation detector with you and validate that what you're buying is actually radioactive. But in the end, it's the same look and it still looks cool, so I like them anyway. And like the claims about AI being made in so many current products, the benefits were often overblown, and in some cases, these products were really dangerous. And at the time, while we didn't know everything we now know about the health effects of radiation, we did know that it was dangerous and potentially deadly to a consumer. So at first, natural uranium was used in the Fiesta Ware glaze. And when I say natural, I mean uranium of the isotopic concentration that's found in the Earth. This was before that we really understood the concept of fission and that uranium would have to be isotopically enriched in order to produce a stable fission reaction. Natural uranium is mostly uranium-238. It's about 99.3% uranium-238, with most of the remaining being uranium-235. And it's that uranium-235 that is the isotope that's needed in higher concentration to create stable fission reactions or in much higher concentrations for weapons production. For the fuel for a normal nuclear power plant, that concentration is roughly 3 to 5%. And in 1943, the company that made the Fiesta Ware had to stop using uranium in the glaze because the United States government confiscated all of the uranium to be used in the atomic bomb project. So Fiesta Red was unavailable until the 1950s when they started making it again, but this time using depleted uranium. So what is depleted uranium? It's what's left over from the processes used to enrich uranium. It's essentially natural uranium that's had the U-235 removed, so it's pretty much just U-238. Now this doesn't affect the chemical or physical properties, so it still works the same in the ceramics glaze. Depleted uranium was used in the Fiesta Ware until the early 1970s until they finally discontinued its use. Now, how radioactive is this Fiesta Ware? Well, you can still find it in some antique stores if you look hard enough, so we set out to find some. Now, there's a lot of Fiesta Ware available out there in thrift stores, and not all of that orange-red color is the radioactive type. There's a modern color called orange poppy that's pretty close to this color, and it's really hard to tell the difference. And keep in mind that they haven't made this Fiesta Ware with the uranium glaze for over 50 years, so it's kind of hard to find. The best way to find out is to take a radiation detector with you. It's really the only way to be sure of what you're getting. We were really unable to tell the difference just based on the look at the color or even the labels on the back. The radiation detector was a must because that doesn't lie. We eventually found a set of 4 of these plates at an antique mall in Florida. So we brought them home, we took some readings. The average number I saw over about 15 minutes was about 0.5 millirem per hour on contact on the plate, and that's about 700 times normal background radiation levels here in this area. I saw studies that said that a dinner plate would read anywhere between a half a millirem to 15 millirem per hour, and that some teacups would read up to 32 millirem per hour, so this plate we found was on the low end of that range. We bought 4 of these plates and all of them read roughly the same. And in case you're wondering if it's any less radioactive as it was when it was first made, the answer is no. The half-life of uranium-238 is like 4.5 billion years, and the half-life of U-235 is around 700 million, so there's really not appreciably any difference between what it was when it was manufactured and now, except for maybe some that had, scraped off or been lost due to use. So how much uranium is in this plate? Well, there's a way we can estimate that using a thumb rule called the Curie meter rem rule. And what that thumb rule says is that 1 curie of radioactive material reads about 1 rem per hour at about 1 meter away from the source. This is a really easy way to estimate how radioactive something is based on a reading at a distance. Now, in order to estimate how much uranium is in this plate, we need to know what it reads at 1 meter away. Now, the radiation detector I have isn't sensitive enough and the plate isn't really radioactive enough for me to get a good reading at 1 meter away, but I can get a good reading at about 15 centimeters away, and then I can estimate what that reading would be at 1 meter away. So at 15 centimeters, I got an average reading of about 0.05 millirem per hour from the plate. And based on that, I'm going to show you how to estimate what the reading would be at 1 meter away. Now, this is an oversimplification with a lot of assumptions, but it'll get us in the ballpark. So assuming this plate as a point source, you can calculate the dose based on an inverse square function. And what that tells you is that the intensity of the radiation at a specific distance squared is equal to the intensity of the radiation at another distance squared. So as you get further away from a radioactive source, the intensity of the radiation decreases exponentially. So based on that, if this plate was reading 0.05 millirem at 15 centimeters, then at 1 meter, it would be reading 1 times 10 to the minus 6, or 1 millionth of a rem per hour. And based on the Curie meter rem rule, that means there's about 1 millionth or 1 microcurie of uranium in this plate. And for ease of calculation, let's assume this is all uranium-238. There's about 3,000 kilograms of uranium-238 in 1 curie of uranium. I know that sounds like a lot, but uranium isn't particularly that radioactive compared to other elements. So based on that, that means there's approximately 3 grams of uranium in this plate. Studies I've read have estimated that there's about 4.5 grams of uranium in a Fiesta Ware dinner plate, which is quite a bit bigger than this salad plate we were using, so this estimate's actually pretty close. So now that we know how radioactive the plate is and how much uranium is in it, the big question is, should you use it? Well, that's not a straightforward answer. There have been a few studies done to estimate a person's exposure based on regular use of Fiesta Ware. One study found that daily use of a Fiesta Ware teacup would give you about 400 millirems per year to your lips and about 1,200 millirems per year to your fingertips. And one study suggested that based on leaching into your food, you'd ingest enough uranium to get about an additional 40 millirem per year of exposure from that. Now, these numbers aren't extremely high levels, but it's still quite a bit higher than I was expecting when I started looking into this. And honestly, my biggest concern would be the potential of actually like pieces of the glaze flaking off and eating it that way. Uranium is an alpha emitter, and while the outside layer of your skin can stop an alpha particle, when you ingest alpha emitters, it's a whole different story as far as health effects to your body. Alpha particles are relatively large and they cause internal damage. That's one of the reasons why radon gas is such a concern in certain areas. So, should you use it? I suppose for occasional use it's fine. But why add that extra risk to your life? There are plenty of options for dinnerware. You can just get the Fiesta Ware that isn't radioactive. It's not like the radioactive Fiesta Ware makes your food taste any better. There's even a modern color called orange poppy that's really close to the Fiesta Red if you just really like that color. So for me, I'm just going to keep it as a curiosity because I think it's cool and it's something fun to talk about. But in the end, I'm not going to use it for my food.